So we'll talk a little bit about some of the challenges we had when we started this journey, I guess, 12 months ago. Arena TV had some very specific requirements around this truck. They wanted it to be unique in the marketplace, be very pioneering. So we sat down with the customer. It was, like I say, it was around about IBC last year. We kind of scoped what was required. So the customer wanted to have a COTS switch at the heart of this truck, no SDI routing in the middle. They wanted to build a truck based on standards, which allowed them to implement other technology from other companies as and when required. So from that perspective, they wanted to embrace the standards that were available at the time, but also look forward to what other standards were coming down the line. Most importantly, whilst OBX is a UHD truck, it also needs to be capable of doing 3G at 1080p 50 and also HD at 1080i and SD if required. So it has to be a multi-purpose truck. And also, you know, it's a large investment for Arena TV, so moving forward, it has to be able to accommodate other types of technical requirements that might come down the line. So things like high dynamic range and also things like high frame rate. And you know, just some simple things like being able to reduce the weight in a truck is quite a benefit for Arena. To be, if lots of trucks going up down the country every weekend for sports, you know, it uses a large amount of fuel. And also things like getting into the rack space in the trucks, trying to remove some of the cabling in and out around that area. But like most things, when we look at the overall cost, if you can do it today in quad SDI, we've got to look at the overall cost of the truck in IP, and it has to be as cost neutral as possible. So what's the challenge? What needs to be accommodated inside this truck? So it's 32 cameras. It's not a small truck. It's a truck that needs to do Premier League football. So a lot of cameras that need to be accommodated. A lot of replay positions that need to also be accommodated. And also, we have to have a fairly large video switcher in the middle of the truck as well to accommodate all of these sources and all of the outputs that are required to deliver all the feeds to the host broadcaster. Other things that are required are things like the multi-viewers. So when I show you some of the pictures later on about the layout of the truck, there's a lot of monitoring positions in this truck. So whether it's production, audio, VT, engineering, or on the tailboard, we have to be able to provide all that monitoring as well. And then, as Daf will talk a little bit later on, is that the deliverables to the client have more than doubled. So now we're not just delivering HD with a stereo and 5.1. We're having to do UHD and with 5.1, Dolby Atmos, stereo, and then you need to make an HD variant of it, and you need to make a clean version of it for the world feed and so on. And like most of these events, you're not the only OB truck that turns up. So there are other OBs that come, take the feed. There are also other trucks that come and do the uplinks, graphics, and so on. So you need to cater for their connectivity as well. So for this, we provided a fairly unique solution around the tailboard, where the tailboard is bidirectional. So you can accommodate lots of ins. They can then come out by using the control system to switch them. And also for the graphics, we're providing a flyaway external frame which can go out into the graphics van and they can patch up, and then it's an IP connection back to the truck. And as this is the first of 3 trucks, it would be quite nice if we could connect up all 3 trucks together via IP rather than large umbilicals of SDI. So where did it start? As with most designs, you normally get a lot of people in a room. You have somebody from VT, somebody from sound, somebody from who's looking over the whole engineering of the truck, and we kind of sketch out what needs to be put in there, and everyone has their input. It ultimately leads to a full block design of all the flows that are going to go around the truck. So what's coming from cameras, where the cameras need to go, how you're going to monitor the cameras, how VT is going to come into the system, how you're going to switch VT in the system, how the feeds then need to make it to the tailboard to go to other devices. So we worked, I would guess, for 3-4 months, Daf, going back and forwards on the design. And we eventually got to map out every single area in the truck. And then that gives us the kind of bill of materials, what the types of products we then put into the truck. So when you look at the design of the truck, it's very different to what we would have in an SDI truck, where you'd have a lot of your core I/O in an SDI router. Here we have a fairly small Cisco network switches in the middle, and then we fan out the I/O to the areas that are around the truck. So each area has its own connectivity as such. So Camera-wise, it's our brand new LDX86N camera, so it's a native UHD sensor. It supports TICO compression natively from the camera base station, and we connect up the base station on a 10 gig connection to the network. Your main output, your monitoring output, and all of your camera returns all being moved around in the IP domain. And the other nice thing is the control system is able to switch the sources back to the cameras as if it was an SDI router stand in front of it. Switcher, so we have our Cayenne switcher. It's pretty much the largest one we have, fully populated. Even though we're IP connectivity, you still need to accommodate the 4 signals internally for the UHD. We're working in 2 sample interleave, which means that we get full 4 MEs running in the switcher as well. And again, we have the IP connectivity directly on the switcher, supporting the TICO. And the one thing I should say is that from a Grass Valley perspective, all of the Grass Valley IP devices that generate UHD TICO streams also generate a monitoring stream. So your TICO stream goes to your switcher, it can go to your tailboard, it can go to your vision mixer, and then your 1080p monitoring can go anywhere around the truck. So that can go to, for example, your multi-viewers. And then we have a lot of gateway cards, and these are kind of our Swiss Army knife for the SDI IP world. So these allow us to take legacy products into the IP domain. It also allows us to bring IP streams back out into a legacy domain to provide connectivity to maybe trucks that aren't IP ready today. So the cards can run in HD, 3 gig, or UHD mode. And as part of the design process we did with Arena, is we added some new functionality to them. So, for example, be able to have 2 10 gigs go to the same card for aggregation. And to do something which you might or might not be aware of is to convert square division to 2SI and 2SI to square division. So, because when you're doing IP, by nature, it is 2 sample interleave because of the compression. But what we want to do is take legacy devices. So, for example, there are some server technologies that are available today that don't do 2SI. So you need to accommodate them. So for what we can do on the IPG card is take that square division quad split and convert it to 2SI, and then all your signals are the same inside the truck. And likewise, coming back out the other side, ideally you'd like to have 2 sample interleave come off your tailboard. But a lot of the emissions encoders that will then transmit your signals are still today's square division quad split. So we need to convert it the other way coming back out. We have a number of GV nodes in the truck, predominantly doing multi-viewing. So when you look at the pictures, all of the multi-viewers around the truck are done by the GV nodes. And also with the GV node, we're doing all the vertically accurate switching inside the GV node as well. So one of the things you can't do in a commoditized network switch is do vertically accurate switching. But we bring the streams into the GV node, and we're able to vertically accurate switch them inside the node. So moving on, so like I said, it's a distributed IP architecture around the truck. We do have to accommodate vertically accurate switching. It's a necessity of a broadcast environment. The video switcher by nature does it. If it doesn't, you've got a real problem. Around the switcher, in the event that somebody pulls the power or you have somebody shuts down the switcher, you have to be able to provide emergency switching around that. So that's accommodated with the GV node. Camera touchdowns, so your guys who are looking at all the pictures in the engineering area and touching down against TX and looking at the other feeds in the truck, they also need to be able to do clean switching. Your VT guys that are doing all your replays and queuing them up and lining them back into the show, again, they need to do vertically accurate switching. And then finally, probably one of the most important people in the truck, your VT guarantee, he wants to be able to bounce around the truck and look at all the pictures very quickly without any disturbances. So I'll just touch on this. There's a lot of information, but although we're talking about COT switches, there are some very specific requirements for the COT switch in terms of how that switch is expected to behave, the connectivity, how the connectivity should behave, and what we require as a broadcast manufacturer when we put our equipment into this environment. So what was chosen for this system was a Cisco 9272. It's a spinal leaf topology using Cisco's non-blocking multicast algorithm. And essentially, this is a token system which prevents you from oversubscribing all of the edge devices. It's a fairly large system, so normally the question people normally ask us is, how big is the system? You know, have you deployed any large systems? Well, it doesn't really get much bigger than this. It's 48 40 gig ports, which are connecting all of the GV nodes, and 230 10 gig ports connecting up all of the other edge devices. That's to give you an idea. That's what it looks like. So it has a kind of mesh architecture in terms of protecting some of the endpoints. So the GV nodes have 12 40 gigs each. 3 goes up to each leaf, which means there's always a path through one of the leaves down into the GV node. And I think Daf will touch on this, but the control system is probably one of the most single important things inside the truck. That's your all-seeing eye. That's what's controlling everything. It's not just controlling the Grass Valley products. It's also interfacing with the CalRec desk and a whole lot of other products in the truck. So VSM was chosen. It's controlling our cameras through our MCP450. So like I said, it's able to resubscribe the streams for your camera returns. You can control the intercom volume and stuff like that on it as well. It integrates also with our multi-viewers, so for your tallies, UMDs, being able to recall the layouts. So in production, it's quite common that you might want to change the layouts. And when it comes to your, what we call our endpoint devices, your gateways, and your cameras and so on, it needs to do a lot more. It's not just routing a SDI in to an SDI out. It needs to do the subscription, which is telling the edge device what stream to go and subscribe to. It needs to be able to also change the different formats, be aware of what formats are in the switch. And also enable, disable the gateways and reverse the gateways. So you would never reverse a signal path in an SDI router. This is one of the benefits of IP, is that that signal going into your system is bidirectional. That single cable, you've got signals going up and down. And on the endpoint devices, we can change the direction of those paths. And then I guess really from our perspective here is we had to look at this. If we had our own control system we could have put here, it might have been a little bit easier. But when when the customer chooses a control system because it has some very specific requirements around the Grass Valley solution, we need to make sure that we're going to integrate with that solution correctly. So as part of this project, we developed a RESTful API for our iControl product, which allows VSM to come down and make all the relevant changes that are required. So kind of a hierarchy looks a little bit like this. You have your control system, which is the all-seeing eye in the truck. It's managing pretty much everything in the truck, even down to being able to manage it on a tablet. And then underneath that is we're managing it from our iControl and then passing the information back up. So what did we learn? We learned a year ago when we started this design that we were still waiting for a lot of the technology to come to market. So TICO wasn't readily available then. But we'd had done some quite a lot of POCs around IP in HD and 3G. So we knew by adding the TICO compression, it was going to be really a kind of a simple step. But as we stand today, it is real. The truck is on air. It was its first outing last Saturday at the Liverpool-Leicester game for BT. One thing I can't strengthen the message enough on is the COT switch. So when you come to build an IP solution, don't assume you can just go and buy a Netgear or a TP-Link network switch. You've got to buy the right switch for the right job. So these are still enterprise class switches with specific functionality that's required for the broadcast space, like the non-blocking multicast algorithm. Like I said, when we set off with this design, because it's a new truck, you go to greenfield and it's going to be UHD. We don't need to account for any other products coming in. Well, with the replays, they are using their existing XT3s. And we're bringing in the 3 gig and bringing it up to UHD for the replays today. Like I said, it needs to be future ready for standards. So as we're using legacy products in the truck, we need to account for black and burst, tri-level. But the whole design is future-proof for PDP, so precision time protocol, so we can also move the timing over that network as well. And in the truck, it's got actually a very complex audio layer in there, which is built around a CalRec desk using a Dante network. And we're using Axon embedders to embed the 5.1 and the Dolby Atmos. So like I said, it's not a small truck. It's about as big as it gets. What does it look like? Well, that's the production last weekend. So the first truck for BT Sport. Like I said, it'll roll to the Everton game this weekend. The second truck, OBY, is about a month away. That will be available early October. And then the third truck is towards the end of the year. So if you want to see the layout for this truck, if you go to the Arena website, they have the layout of the truck, and you can see some of the information about it there. This was last Saturday, so the Arena team all gearing up for for this big outing. As you can see in the TV complex, with the big one from the right at the top, you see there's a lot of other trucks in and around us that need to connect into the system. So when we come and do these types of events, you can't just take the approach that it's just you and you have to ignore everyone else. Even though you're in an IP domain, you still need to think about the larger audience you're going to connect up to. The camera guys with our new 86Ns. And then, like I said, this was one of the first outings, but nicely it coincided with also the Dolby Atmos being introduced into the truck as well. So I think all in all, it was a great success. From the initial planning right through to delivery was about 12 months, working very closely with the customer to do this. Like I said, all of the products that are in this truck are available today. There's products you can go and buy. And like I say, if you've got any questions, I think if we invite Daf up also to maybe give some input into from the customer side.